innovation, MSME assistance, capacity development, and collaboration and partnership.
A Fab Lab is an interdisciplinary space that promotes innovation through the use of digital fabrication tools. It's a modern facility that allows our SMEs to do prototyping. For the last 1.5 years, we have been teaching them digital fabrication skills, which are very much in demand in the world market.
For us, it really would support creation of maybe high-end products and development of new enterprises that are technology-based.
This one will be the common service facility of industrial designing in the province of Bohol. There are even seminars, conferences, workshops conducted here so that Fab Lab enthusiasts and other designers could use the facility.
The concept was introduced to us by our Japanese volunteer, Mr. Yutaka Tokushima. He noticed in the course of his product development activities here, he noticed that a lot of the problems in prototyping could be solved if we had the right equipment to do it.
We've catered SMEs to really expand their market into the tourism sector.
We have all these industries, and ang thing is they're all kalat-kalat and they're all spread out, and I think having this Fab Lab would bring them all together.
True to its thrust in catalyzing innovation, DTI, through Fab Lab and its local partners, has initiated key programs, projects, and unique initiatives in the areas of waste upcycling and material engineering. Prefabricated shelter designs, startup support and development, equipment development, and knowledge hubs for new innovations. True to its thrust in catalyzing innovation.
The timing man nga ning abot ang tagahapon nga mo naa sila ihatag. So mao to nga nalipay may kay ni aning abot ning kiwi. Kiwi house nga mo di magkakaroon na mo serve as daycare center.
Key MSME assistance initiatives such as product design, product development, productivity enhancement, and marketing solutions have been significant drivers in the improvement of grassroots entrepreneurs and homegrown innovators.
We do some native bags, placemats, wallets, curtains, and lately I do trophies and medals for the triathlon with the use of Fab Lab facilities.
The problem that artisans face here in Bohol are really the same challenges that any small business faces across the world, and that's how to get your product in front of your customer. So we developed a kiosk called the Made in Bohol kiosk and sought to have it located in the luxury hotels where the tourists were staying.
Pag butang nimo aning dating molder na mo, pag butang nimo, patigasin pa. In pila ka minuto pa usa pa nimo matanggal. Pero kini siya, gasigi pamighimo ana, kasi mo iwa pa mahuman ng uban, pwede na mo siya itaktak kay gahi na. Wala na kay minuto o oras nga magamit aron pa mugahi aron maputos. Kani siya diretso na. Mas daghan, mas napasayon, mas niangay ang among customer. So dako kay natabang ang Fab Lab sa mua.
Ang improved na siya nga sticker namo sa bagol na siya kay ang among kanister is naka-embed man siya sa taklob. So kani siya sa bagol na siya. Kay before mag-cut out man ni kami mag-print, ordinary lang nga bond paper ang gigamit, kami na mag-cut. So karon nga naa diri introduce siya sa DTI. So nagning try ko nga magpa-print. May ganahan na sila. Sila, oy, nindot lagi mag-packaging. O, kaan lagi ni, klaro kaayo. Oy, sinaw na lagi ni. Kanang nga na siya na mga feedback na yun, ana.
When Fab Lab came, we had this partnership with them para maging competitive din tayo sa market. So, eto po yung isa sa mga naitulong ng Fab Lab. This is our newest package na po sa mga placemats po namin. Madami po kaming nabenta na po nito, and we're very thankful to Fab Lab. Tumaas po yung income ng kooperatiba. Kasi may added value po yung mga produkto na namin.
To fuel global industry competitiveness, local entrepreneurs, Students and innovators are brought together to equip them with 21st century skills and tools through digital fabrication, technology trainings, and livelihood trainings and seminars.
It's for everyone. I would say a lot of people really likes to make almost anything. Doon, merong bata, merong matanda, merong zero knowledge, merong may medyo alam na. When you see people came in and then yung parang may sparkly eyes sila dito. When they came like, oh, pwede pala to siya. Pwede palang gumawa ng ganito.
The Department of Trade and Industry conduct workshops and trainings for those because they want also to help those young local people here in the country. Because they want also to enhance their skills, improve their skills by the use of the FabLab Bohol. So, because FabLab Bohol, the concept of FabLab Bohol is to innovate and to create inventions by the use of digital fabrication.
This FabLab should be duplicated in other regions because this is a good avenue for developing the skills of designing on the students' part so that we could be ready or we could be at par with other countries in designing.
It's actually, for me, it's like a gold mine, a gold mine for innovators because everything are there na. Laser cutter, the shop boot, 3D printers, Arduinos, mga testers, na ito.
As of now, there are so many micro and kitchen-based enterprises that would really need to improve or upgrade their technologies, their equipment. And that's why we are supporting FabLab because it is our vision that this facility could help those in making those customized equipment.
The FabLab affords its users access to global knowledge through regular educational tours and access to the international FabLab network. Local and other Philippine startup communities, enterprises, designers, and enthusiasts are encouraged to collaborate amongst themselves to expand and strengthen their niche in various market networks.
ボホールではファブラボを使って、必要なものを必要な分だけ作るというイノベーションが徐々に現地の人の手を使って生まれてきています。これは、他の国のファブラボでは見られないようなボホール独自のイノベーションと言えるようなものです。
The laboratory boasts of an array of digital fabrication equipment which include a laser cutter, 3D printers, a digital embroidery machine, a print and cut machine, a CNC milling machine, and an automated wood milling machine. FabLab Bohol also houses a pool of passionate in-house designers and highly skilled staff who can assist in 2D and 3D design, skills training, modeling, and production.
Our task here is to assist those researchers, innovators. So what we did here is not for us to create their idea, but them to create by themselves, and we will assist.
In partnership with the DTI, Bohol Island State University, DOST, and the Japan International Cooperation Agency, or JICA, and the local community of enterprises, FabLab stands at the center of innovation in Bohol.
We are very thankful of the help of the DTI. They can give you a very good service and you really can come up with a very good product.
Kasi we want to be Gandum Weavers to really soar high, and our partnership with FabLab will bring us to that level. So thank you po FabLab and DTI.
I encourage everyone, especially taga Bohol, mga students, mga innovators, or mga out-of-school youths, try mo sa FabLab. If ever wala pa niyo nakit ang imuhang gusto himo no, basin naano mo kita sa FabLab.
It's a great privilege bitaw sa ato kay na natagan tag chance nga matagan og FabLab diri nga makita mo ma-amaze jud mo sa mga magama ning FabLab matabang niya para nato sa Bohol.
If you wanted to build a robot or night vision goggles or just something that lights in the dark, this is the place for you.
I would like to invite everyone to come at Fab Lab and let's play with these machines and let's work that idea out.
きっと皆さんのアイデアと、ボホールが持っているイノベーションがそのコラボレーションすることによってさらにもっと面白いものになると思います。ぜひ皆さんボホールにお越しください。
Fab Lab Bohol, a place where ideas turn into reality. Ideas that can improve lives, not just for Boholanos, but for all Filipinos.
Mga kababayan, ang pambansang awit ng Pilipinas.
Kayang mag-ibig, ewas ng sinakanan, alam ng puso, sa dibdib mo'y buhay. Upang hinirang, tuyag ka ng magiting, sa manlulupin, di ka pasisingil, sa nagatang tutok sa simoy at sa langit mong bagaw, ay hinatang tulad, awit sa paglayang minamahal, ang isang ng matawad mo'y tagumpay na nagtitindig, ang bituin at araw niya kailan pang ay di magtitindig, luman ang araw ng walang pagsinta, buhay langit sa piling mo. Ang hindi kaya na patay mga amin, ang mamatay ng dahil sa'yo.
Hello. Good day. Maayong adlaw. Magandang araw. I am Lip Coronado from AMSEN, and today I would be your host. Welcome to FabFest 4, Fabricating the New Normal, in which it would be held on November 24 to November 27, 2020. In line with this, there are a series of webinars that started last November 4, 2020 up until now. This is brought to you by the Department of Trade Industry, or DTI, in partnership with the Department of Science and Technology, Advanced Manufacturing Center, or DOST AMSET. May we remind all the participants here that we are live via Zoom and Facebook, so please share it, and together, let us learn from our experts. Our topic for the day is very interesting. It is entitled PCB 3D Printing, Bridging the Gap for Hardware Engineers. Our speaker will be from Canada. He's a foreign expert, and we're lucky to have him to formally introduce and give us the idea of the topic. I would like to call on one of the science research specialists in AMSEN, Engineer Kim Harold Lopez. Take it away, Harold.
Thank you, Sir Lee, for that. So, to start with, in our day, technology is advancing faster and further. We see this speed most clearly in the software industry. Each year, creative minds from all over the world churn out a whole host of apps, games, and other professional softwares. And no doubt a factor of this speed is their access to quick software prototyping. Software engineers can hit the compile button, check, debug, and iterate their code until they achieve their desired goal. So what if we can do the same for electronic hardware, specifically for our printed circuit boards? So here with us today is Sir Roy Perez, an electrical engineer by training and an application specialist at Voltera. He's worked with companies big and small, from small-scale startups to Fortune 500 companies such as Microsoft, Apple, and Google. Today, he'll be introducing Voltera's solution on challenges of prototyping with PCBs, the Voltera V-One. Sir Roy, it's a pleasure to have you. Morning, sir.
Good morning. Can you guys hear me okay? You guys can hear me? Yeah?
Yes, sir. Yes, good morning.
Good morning, mabuhay.
Good morning, mabuhay po.
Like he mentioned, my name is Roy Perez, and I'm one of the application specialists. Let me go ahead and share my screen for you guys so you can see what's going on. Can you guys see my screen okay?
Yep.
Perfect. So yeah, my name is Roy Perez, and I'm actually Filipino in my background. My parents are from Mindoro, so it's an absolute honor to be able to present to you guys and share a little bit more about what Voltera does and how we bring hardware to life at Voltera and how we try to spread that idea through the products that we create. So I wanted to touch upon just the subject of bringing hardware to life. And I wanted to start off with a question. Does this sound familiar to you? So you're an electronics engineer or a student or someone who wants to dive into the world of electronics, because as we all know, the world is rapidly changing faster than we can say chicken adobo. Or you're someone who's been put in charge of shaping the way your classroom learns or how your lab develops. Okay. And it all starts with the hardware. All technology starts with hardware. And hardware starts with the circuit board. But access to circuit boards is difficult. Access to PCBs isn't exactly easy. So whether that's your iPhone, your laptop, your cameras, it's difficult to access PCBs and develop that technology easily. So this next slide here is the typical hardware development timeline. And this is what it typically looks like for anyone in product development or anyone working in a fab lab. First, you start off with an idea. You have an idea and you decide, okay, I want to bring this idea to fruition. So you come up with a design, a schematic, and you reach out to manufacturers and you get them and submit your idea to them, only for them to come back and say, you need to order 25, 50, 75, maybe even 100 pieces before you can place an order with us. Okay, so you decide, okay, I'll go ahead and place that order. A week goes by, 2 weeks goes by, and you get your 100 pieces back and you realize that you've made a small error, a small design flaw. We're only human, that happens. And of course, with any engineering process or any type of development process, that's bound to happen, right? So you iterate again, you fix your design, you fix your idea, and you send it off to the manufacturer again, only to wait, another week, another 2 weeks, before you kind of get into the cycle of, you iterating, you're going to the manufacturer, and there's this back and forth between the two. And you do this 2 to 3 times, maybe even 4 times before you finally get to somewhere where you're confident in what you've designed and what you're bringing to the mass manufacturer, and what you want to bring to the market, essentially. But hold that thought, because the question is, why is this still a problem? We live in the 21st century. We live in a digital age where we literally have the world at our fingertips. We can order food from our phones for delivery. We can order transportation from our phones. We can order the basic life necessities and have it delivered to our doorstep the next day. So why is this still a problem? And for software engineers and software students, they don't have this problem. They really have it a little easier than product developers. They have a compile button. They have software that'll point out what error and what line the error comes on, and how to fix it, and where to change and iterate. So software engineers have it different. And before I get into that, I wanted to tell you a little bit about the history of Voltera, a little bit of history of myself as an electrical engineering graduate, and the current prototyping methods that are used today. So the three main prototyping methods are the three here that I've laid out for you. So first is outsourcing. Outsourcing, just like how I mentioned before, you have an idea, you reach out to the manufacturer, you submit your design, you have an MOQ of 100 pieces, and you go through this iterative cycle of back and forth, talking to them, waiting for weeks and sometimes even months to get your design finalized. Okay, so that's the first prototyping method. The second method is a milling machine. So while milling machines get the job done, they're expensive to purchase right off the bat. They aren't clean. They're messy. You're subtracting a material away, so there's a messy process there. And the user experience itself, the user experience is not intuitive, especially for students and educators looking to teach the next generation. So the user experience isn't that great. And the third method is chemical etching. Now, while this might be the most inexpensive way to go about prototyping circuit boards, it's not necessarily the easiest, and it's a little bit of a hacky process, essentially. So you have your chemicals, you have some containers, you have your boiling water, maybe a hacksaw, a drill bit, and it's kind of all over the place, and it's not really made to teach or made for people to explore. Okay. And that last method is what my colleagues here, so my colleagues Kat, Jesus, and James here, this is the exact process that they decided to go through. They decided to set up shop in the University of Waterloo bathroom to go through the chemical etching process. And they were going through the same ups and downs that come with being hardware engineers. Now, I study electrical engineering at McMaster here in Canada, and after 3 years of drilling electrical theory into my head, we were then expected to come up with a product or a project that was working by the end of the year. And that was within an 8-month time span. And it's a classic case of catch-22. They want us to build something, but we don't have this experience in doing so. So my colleagues, they knew there had to be a better way. I knew there had to be a better way. So they started working on a tool. And while they're working on this tool, it was during the time of the makerspace movement. There were 3D printers out there that were becoming more available to the masses. Creatives, educators, students had access to them. And at this point, creating physical products had gone from anyone who had capital budget to anybody who had them in a school, in a fab lab even, in a research lab. But something was still missing, and the electronics aspect of it was still in the slow lane. And product developers still needed circuit boards to add functionality to these physical mechanical projects. They needed the brains of the project. So that's how they came up with the Voltera V-One, the 3D printer for electronics, a desktop PCB printer that sits right on your desk, and you're able to produce a prototype within a day, within hours even. So how does the V-One work exactly? And I have a short video here made by my colleagues, and my colleague Kat walks through the V-One printing process and the steps required to print with the V-One.
Hello, sir. I think there's no audio in your video.
That is right. Give me 1 second here. Share screen. This should do it. Let me restart that.
Hi everyone, I'm Kat, co-founder at Voltera, and today I'm going to be showing you how to make a double-sided circuit board with the V-One. So step 1 is to upload your design files. You could use any software you're comfortable with, just upload them into Gerber format. You'll see the toolpath is already calculated when you upload your design. So next, clamp down the sacrificial layer and the board. I'm using it, we're going to be drilling into it. So once that's secured, snap in the proximity probe. It will be used to generate an accurate map of the surface. So once that's done, go ahead, snap in the drill head and fire it up. Now the board has been mapped in XYZ space, so the drill knows exactly where to go. If you're going to be using different hole sizes, the software will prompt you to change the drill bit after the current hole size. All right, let's print some traces. So swap out the drill head for the ink dispenser, let it calibrate, and begin laying down conductive ink. If you find a mistake on the board, you could easily reprint it using selective printing. This is a great feature for design modification and rework. Okay, so now it's time to cure this board. Simply remove the sacrificial layer, flip the board, and rest it on the baking ledges of the clamps. Curing takes about 40 minutes, and you're going to want to let it cool down after, so I'm going to go grab a snack, and I'll be right back. Okay, so that looks good to me. Now I'm just going to flip the board back over so that we can print and cure the bottom side. Okay, so our traces are printed and cured onto both sides. Now I'm just going to go pop in some rivets and use the riveting tool to secure them into place. Okay, with that done, we can clamp the board back onto the printer and go ahead, snap in the solder paste dispenser so that we can get some solder onto these pads. And with that done, I'm just going to pop some components onto here and watch them reflow directly onto the heated bed. This board does have a few through-hole components, so I'm going to go solder them using the provided solder wire. I'm using plenty of flux, and my iron is set to 200 degrees Celsius because the traces are heat sensitive. Okay, so let's see if my punk console works. Okay, so this is an example of a very simple circuit. Thank you all so much for watching. We can't wait to see what you create with your V-One.
Perfect. Hi,
everyone.
So, as you guys saw, you guys can still hear me okay? Yep. Okay, so as you guys saw, it's an additive process where you deposit a silver nanoparticle conductive ink onto a substrate. And in many cases, it's typical rigid substrates FR1 and FR4. And as she highlighted, there are 4 main steps to the V-One printing process. First, you would drill your through holes that allow you to create the double-sided board. Second, you would print the conductive ink onto the substrate. Third, you'll dispense your solder paste onto the conductive ink itself. And then you would reflow that solder paste to your components, which it essentially act as a joint between the conductive traces and your components, okay? And that allows the conductive connection. So this is what it used to be. This is what the typical product development cycle looked like in terms of circuit boards. You had your idea, you went to a manufacturer, you bought 100 pieces. It took 1-2 weeks to get it back. You get the 100 pieces back, you have a design fault potentially, and you iterate until you kind of go back and forth with the manufacturer until you're happy with it, until you have something that's for the masses, okay? But with the V1, what it does is it levels out the playing field. You no longer have to sit around and wait on somebody else or rely on anybody else. And our goal was to eliminate the time-sucking parts in the hardware development cycle. And this opens up a lot of opportunity to take your fab lab or your classroom to the next level. You're cutting your development time in half, essentially. You've cut out the middlemen and you just have these 3 steps to get to where you need to be. So if you're a student, what this means for you, if you're learning the fundamentals of electronics, you can put theory into practice now by having that hands-on experience. Being able to put that deliberate practice in, just like a software engineer would. And you would try and you fail, until you finally got success. Okay, so as if you're an engineer who's not working at your full potential, who's not being able to be as efficient as possible, you don't have to wait and rely on anybody else anymore. Or you're a fab lab manager, you're an educator who's looking to empower that next generation of engineers. And again, not just with theory, but with that hands-on experience to nurture that inner scientist that's within everybody. And that's what the V1 allows you to do. There's somebody I'd like you to meet. I'd like you to meet Sherman, who was a former co-op student for Voltera. And he was tasked to take the Voltera to its limit. So here's what Sherman was able to come up with.
My name is Sherman. I'm a hardware designer at Voltera. What I made was an 8x8x8 LED matrix, except as a twist. Instead of using normal through-hole LEDs like most people do when they make an LED cube, I used surface-mounted LEDs that were reflow soldered onto layers of transparent PET, which would normally be either impossible or very difficult because you would have to solder the leads directly to the LEDs. With the V1, we can do reflow onto a bunch of different substrates, including ones that are transparent. So I was just trying to check the capabilities of prototyping on Flex, especially with regards to soldering and reliability. Because this project, there's a whole lot that can go wrong, especially with 8x8x8. So that's 512 LEDs you have to reflow solder. There's a lot of traces, and if any one of them breaks, then you know that the process isn't going to be reliable for prototyping on Flex. I learned a whole lot about printing with Flex. So Flex is kind of a unique substrate, unlike normal FR1 or FR4 that most PCBs are made of. During the printing process, as well as the curing process, it likes to bow out and expand and sometimes even warp a little. So you have to pay very close attention to make sure everything is perfectly flat, both during printing, otherwise the print height won't remain constant, and as well during curing, because the heat itself likes to make the substrate flex. So luckily we have thought up a good method, and that is with using magnets to hold down the substrate onto a steel plate. So these magnets are very easy to apply, and they are very good at keeping the substrate flat. Prototyping on Flex, I think, has virtually been unheard of. Like before, I had never even heard of doing a project with Flex at all because there's a very large cost associated with getting Flex PCBs manufactured in the first place. So the V1 is really what made it possible at all. With Flex, there are just loads and loads and loads of applications. So one of the biggest ones is doing RFID or NFC tags. Normally, you'd have to buy the antennas yourself from some third-party supplier and work around their constraints. But with the V1, you can print your own antennas to whatever spec you want. Flex also has a lot of potential applications for wearables, including embedded sensors for health, for fitness, tracking, as well as in compact environments, since the Flex can bend to unusual shapes, and it's also a lot lighter than rigid substrates. So in applications like aerospace or in satellites where weight is at a premium, Flex can help a lot. I remember seeing the opening on the job posting site at Waterloo and thinking it was called Builder of Hardware, and the job description was pretty much just to have fun with hardware, to take the V1 and build stuff with it to prove that we can do things with it and to validate it and to show the world what we can do, its capabilities. So I thought, wow, that sounds really cool, both from the perspective that I can kind of explore projects and learn about things that I want to, but also just working with the V1 at all is pretty amazing. As until now, the world of PCB prototyping has been pretty intimidating, even for an engineering student like me. I mean, to get it done, you need to get quotes from manufacturers, and you have to do all sorts of crazy things, acid, etching, considering tolerances and whatnot. And I think the V1 kind of brings it a lot closer to home. So now you can see it on the desk, you can see it printing. So by finishing this project off, we kind of did a proof of concept to prove that, yes, With the V1, you can do stuff with flex, and it is reliable, and we can actually use this in industry.
Perfect. That's Sherman.
My name is Sherman.
So that's one of the ways that the V1 is used. He kind of took a mix of both flexible substrates and rigid substrates and put them together to make that 3D LED cube. And the typical way that the V1 is used is to shorten the path to production. Anything and everything regarding your traditional rigid substrates in prototyping, the V1 can do, from power supplies to antennas to NASA building CubeSats, which are mini satellites, and sending those out to space to collect data, from Belkin smart home IoT applications, companies that are building concussion monitoring systems in sports equipment, or art teachers or art professors creating modern day musical instruments using electronics. Another way that the V1 is being used today is a teaching tool. So in Korea on the left, that's an electronics undergraduate classroom where there's a V1 on almost every student's desk, or on every student's desk. And that teaches them not just the theory, but also the practical side of things in real time. And on the right there, STEM Power, an organization that's implementing STEM programs in Ethiopia and other nearby countries, they're teaching pre-university students to learn through hands-on experience as well, and that enables them to have the skill sets for future STEM studies and future STEM careers later on. And it's not really stopping at just those two. We're finding that there's much more to it than just traditional PCBs. We're seeing a lot of new opportunities out there. There are smart interfaces, dashboards, smart windows. BMW is using it to prototype heated seats. Stanford University is creating biosensors for health monitoring. Clothing companies like Nike are using it for truly wearable technologies, and Amazon is using it for smart packaging. Microsoft recently had a initiative, environmental sustainability initiative, where everything from concept to production had to be environmentally friendly and environmentally sustainable. So they're printing on biodegradable materials. Here's another professor printing on biodegradable materials here. He's from Queensland University in Australia, and specifically what he's printing on is waterproof lignin craft paper. Why? Because it's both recyclable and renewable. Lignin is a byproduct of pulped wood and pulped grass, where typically coatings that go on packaging products are made from petrochemicals. And once you have petrochemical on those packing materials, they end up in the landfill. They can't be recycled. So those are just some ways that the V1 is being used today. Where else is it being used? Like where? In education academia, whether you're an undergraduate student at MIT or you're a researcher at Stanford or Berkeley, hardware development is universal to everybody. And not only is it just for academia, but industry professionals as well are using it. Facebook, GoPro, NASA, Dyson, they're all using it because hardware development is happening everywhere. Hardware development is a universal problem that we're looking to make quicker and to solve. So I wanted to bring this photo up because, as we know it, this looks like kalat.
For new innovation, true to its thrust and catalyzing,
kind of all over the place. And this is the typical way of teaching electronics or even prototyping as a product developer. And while breadboards are great, don't get me wrong, they're great. They're not necessarily representative of what circuit board manufacturing is and what the design aspects are. So having knowledge of breadboards is not necessarily equipping developers and students for that next level. And I like to make the analogy of building a house. When you approach a structural engineer, you don't tell them to buy the foundation, buy the windows, buy the walls, buy the roof, because there's an important design aspect that every civil and structural engineer would need to know. And that is the same case for electrical engineers. There are certain design aspects that we have to consider. And students can learn what's involved in designing a circuit board, what's involved in component placement. They can learn about choosing the proper bill of materials and board management. Engineers can become more efficient in their product development cycles, and engineers can bring projects to life faster, and that allows them to focus on innovation, right? And there's one last person I'd like you to meet. Her name is Shannon. She's an undergraduate at Princeton University. She enrolled in Princeton's aerospace engineering program. She's a freshman. She's 17 years old. She didn't have access to these types of tools before going to Princeton. And a lot of theory and a variety of experiences in her life happened in other areas. And we found out that this upcoming February, her designs are being shipped out into space in February because of using the V-One. So meet Shannon.
Rather than seeing it as daunting, I see exciting. What could be out there? I mean, there's so much that we don't know. They say like the laws of physics, but really like they're like the laws of physics as we know them. What is life? I mean, it's life as we know it. That to me is what's most fascinating about it. My name is Shannon. I'm a freshman at Princeton. I'm planning to major in mechanical and aerospace engineering, and I'm from Virginia.
CubeSats were invented about 20 years ago by Cal State, San Luis Obispo, and Stanford. But they turned out to be pretty difficult projects, maybe more so than the original inventors expected. All of the challenges that you have with a large spacecraft are still there to some degree with a small spacecraft. So it's really one of the hardest projects that humans undertake is the design of an autonomous on-orbit spacecraft.
I actually found out about the project through an interest meeting for the Rocketry Club. You know, you get to launch a satellite payload that's going to be launched like during a resupply at the space station. I had done like a lot of camps where we designed like theoretical space missions before, and so the idea of being able to actually launch something that goes into space was really cool to me, and so I immediately was like, I really want to do this.
I'm setting up our small spacecraft design lab with a strong focus on enabling our students to make every piece of the spacecraft in-house here, to see something actually get built and get launched during their undergrad tenure. You know, before they graduate, they can see a small spacecraft through from conceptual design, through preliminary design review, through detailed design, integration, build, fabrication, all the way through spacecraft qualification tests, integration for launch, and then finally just orbital launch from the launch site.
I think it's pretty exciting because a lot of times if we didn't have something like the Voltera V-One, if we didn't have the PCB mill, we would maybe get to design the circuit, but then we just send it off to a company. And I don't think I would have fully really understood what goes into a circuit, but now being able to actually see that like this is like this place where the electronics go, like using it actually helped me a lot to understand like what goes into a circuit and what components go where and all that stuff. So I think it's really beneficial to be able to see, will this stuff work in space? Because if it does, then that will be like a really great way for all these universities and even high schools that do make ThinSat and CubeSat payloads to be able to use them. When I came in and was deciding between majors, working on this project really made me want to decide officially on doing aerospace.
Perfect. Okay, so that's Shannon. So with that being said, us at Voltera, we've been at this for years, and we're only scratching the surface as to what's to come and what we can do. And our biggest vision right now is making hardware development accessible to everybody. So whether you're an educator in Manila, Philippines, or you're a tech guru in the heart of Silicon Valley, we truly believe that hardware development can be done quick and easy and should be available to everybody. And at our core, we truly believe that nothing is impossible, and we help turn ideas into reality faster and we do so by empowering innovation. So thank you so much. Salamat. If you guys have any questions or you guys want to chat afterwards even, you can reach me at my email below, roy@voltera. And you can also check us out at voltera.io. Check out our website, check out the product a little bit more, and I'd be happy to answer any questions.
Thank you, Sir Roy Perez. We will go ahead and take some time for questions now. Just a reminder, please be sure to type your questions in the question box in your control panel. Also, I have few questions, Sir Roy.
Sure.
About the material of the conductive ink, do you have only one type of material for that, or?
Yeah. So right now, so actually, it's mainly silver conductive ink. It is silver conductive ink. Now we do have empty cartridges that researchers use to fill with their own materials. And we also have a flex conductive ink, which is also silver. And that's meant for any flexible applications that you guys saw in the videos. But yeah, we have users printing graphene, insulative inks, biodegradable materials, gold, copper, all sorts of things. And ideally with the V1, as long as it's viscous enough, as long as it's almost like ketchup, essentially, the better it will be to print with the V1.
Okay, thank you, sir. So there's a possibility to use dielectric or even what you call other insulating ink.
Yes,
in the future,
absolutely,
right?
Absolutely.
What is the build size or the size of the printer, sir?
The V1 is about 15 inches long by 8 inches wide. So probably around the size of a laptop, a average size laptop. It's pretty small a small form factor, so it sits right on your desk.
Thank you, sir. So it's good for prototyping. I've also experienced that prototyping could take days or weeks in an electronics company. How about, sir, the sizes of the milling machines? What are the smallest and the largest, or what type of tool? What size of tool can we place on the PCB?
So there are three tools with the V1. So there's the probing tool, and that allows you to calibrate and determine where the substrate is in physical space. So it allows the computer to say, hey, this is how big of a substrate I'm printing on, how thick of a substrate I'm printing on. So the probing tool is used for that. Then you would have a dispenser mechanism, a dispenser tool that prints out the conductive ink itself and the solder paste. And those are actually the only two that you would need, as well as the drill attachment. So the drill attachment has different size drill bits, just like any sort of handheld drill. It has a chuck where you can input different drill bit sizes, and we provide those with the printer as well.
Oh, nice, sure. So we can also explore. Are Voltera open to if we try to use different substrate or even inks? Can we do that?
Yep, absolutely. Yep. Different inks for sure. We just recommend that it's viscous enough, and we have some recommendations on that. In terms of the substrate, we have people printing on things like glass, ceramics, carbon fiber. As long as it can withstand the curing temperature of the ink itself, you'd be able to print on it.
Okay, sir. How about, sir, in 3D printing, there's slicer software, or in there's CAD/CAM in milling machines. How about the free software or slicing applications in this? Do we have one, or how do we prepare it?
So do you mean like a milling or routing aspect to the V1?
Yes, sir. How do we create from our CAD file or our yes? from our CAD file to how do the Voltera one read it?
Yeah. So the software, which is on our website, free to download, you upload a Gerber file. So what you do is you design your schematic in Altium, in Eagle, in KiCad, whatever PCB design software you have. You would export your file as a Gerber, and you would upload that to our software, which then converts it to G-code and generates a toolpath, which allows you to print the conductive ink.
Okay, sure. Thank you for that.
Yeah.
How about are there any challenges that you would like to share about development of V-One? Is there anything?
Of the V-One itself?
Yes, sir, or from your experience.
And do you mean in terms of me developing something on the V-One or actually developing the product itself?
It can be both, sir. Just to share and give ideas to the world.
Yeah, I personally haven't been part of the product development stage itself, but I know our engineering team works hard day and night to ensure that they're constantly improving it. So I know there are struggles, and we always take customer feedback and take that into to see how we can improve it for them. In terms of my own product development, I haven't been necessarily part of a large project using the V-One, but there are in university, I had that aspect of product development where I had no idea how to go from my design to a fabricated board in a relatively short amount of time. We were given 8 months to create something out of a concept. So that struggle itself has brought me closer to Voltera and the V-One, and allows me to, empathize with the users that are using it.
It looks like we have one question from the chat box. How long will it take to make a board? I think she is referring to the typical average time. Can you give them more idea?
Yeah,
Thank you, sir.
yeah, that's a great question. So on average, depending on the complexity of the board, it could be about an hour to 3 hours. And that's from start to finish, from drilling your through holes to printing your conductive ink to solder pasting and to reflowing. Now, if you have a fairly complex design, it'll take about 2 to 3 hours to get it done. But you should be able to get something physically in your hand by the end of the day.
Thank you, sir. How about, sir, the adhesion of the ink, the conductive ink to the substrate? Is there any issues or limitations in terms of that?
There would be one limitation in terms of temperature. So if you're hand soldering anything with the conductive ink, we have recommendations to stay within 180 to 200 degrees Celsius. Anything above that, you start to affect that adhesion. But as long as you stay within that window, you should be fine.
Thank you, sir. We have another question from Sir Jockey Padaka. We noticed that there were manual processes in between printing steps, like the riveting process. How close are we to the possibility of having a fully automated system?
Yeah, that's a great question. We get this question a lot in terms of how can we fully automate the system. And I can't reveal too many details regarding that, unfortunately. Otherwise, my colleagues will kill me. But that possibility is there. We are constantly working to optimize the V-One for feedback like that. But it does take time to develop things like that. So I can't reveal too much information on that, but we have had that feedback multiple times, and we are very much considering it. Let's put it that way.
We understand, sir. Is there any questions? Not. Okay, sir. Is there anything you want to add, sir, or what do you see are the next stages of Voltera for next projects? V-One? What?
Yeah. That's a good question as well. And like I mentioned in that last slide, is we're really focused on empowering innovation, and that starts from students to Fab Lab users to maker spaces to researchers, and empowering innovation is at our core, and how we build tools around that is what we're trying to do. And we're doing that. We are a small team, but we're doing that slowly but surely, essentially. And that's kind of how I would summarize Voltera. Is we're looking to empower innovation, and we're doing so by bringing the tools for people like yourselves.
Thank you, sir.
Yeah. Thank you.
Is there any question from the viewers or participants? If none, it looks like we covered all of our questions, Sir Roy Perez.
Yeah.
Is there something you wanted to cover before we wrap up?
Yeah. Somebody asked, actually, do we ship to the Philippines? We definitely do ship to the Philippines. We are working with our partners at OmniLab, who we're working closely with, and we definitely ship to the Philippines. If you guys do want to get in touch again, my email, I'll give my email out to the hosts, and they can share it with you guys. And you guys can check us out at voltera.io and chat with us there. And we'd be happy to answer any questions that come up after the presentation.
Thank you, sir. Actually, you can type in now your
yes.
your email, so they can contact you if there's a question.
That is a good point. So this is my email. In case you guys have any questions, you guys want to chat, have a call with me, just chat about additive manufacturing, PCBs, whatever it is. I'm open to chat with you guys.
Great.
Yeah, and I just want to say thank you guys so much for hosting this and allowing us to share a little bit more about Voltera. We're happy to spread the word and happy to connect with people like you guys.
We appreciate.
Thank you. Thank you.
Thank you so much, sir. This is the end of our webinar. We are now free to go.
Thanks, guys.
Thank you.
Thank you, sir.